Alright, today's lesson is going to be an interesting one. We're going to do the geometric proof of basic algebraic identities. So what are these basic algebraic identities I'm referring to? They're listed on the board here. So there are three of them. They're very important. Okay, the first one is a plus b square is equals to a square plus 2ab plus b square. The second one, a minus b square, is a square minus 2ab plus b square. The last one here, a plus b multiplied by a minus b, is equals to a square minus b square. So if you're in high school, you're in secondary school, you're asked to memorize these identities. Okay, they're very important. They come into handy a lot of times. So please memorize them. But today I'm not going to talk about memorizing them. I'm actually going to show you how to prove them. You will not be asked to prove them. Okay, very unlikely that is the case. I'm just showing this because it is interesting and hopefully it interests you. So the first one, I'll prove it, okay? So I'm going to do a geometric proof, which means it's going to involve shapes. So I'm drawing a square that is quite ugly as a square. But let's just imagine this is a square, okay? So this square, I'm going to cut it like this, okay? Okay. So I've cut the square into 4 pieces, obviously not equal pieces at all. So the first one I'm going to write here is, this is A. So this is of length A, okay? So which means because this is a square, so this is also of length A, okay? This is going to be of length B. B, okay? Alright. Now, so to find the whole area of this square, we would write this is basically a plus b squared, right? It is this whole length squared. So it is a plus b squared, right? So let's try and find the individual components, okay? So this area here is a squared, am I right? And this area here is b squared, correct? Now we're left with two sides. This is A and this is B. So this is A times B, correct? So I'm done with this. So this side and this side is the exact same. So this is also A times B. Now all I have to do is just add it up. This is 2AB. So that's it. Easy peasy, right? So this is how it looks when I do a geometric proof. Okay, so now we do the second one, okay? Hopefully I have some space. Okay, I'll do it here. So again, I'm going to do something similar, but of course a bit different. So again, it's a square. That does not look much like a square, but that's fine. Okay. Ooh, sorry. Now, I'm going to cut this again, okay? This time, I'm cutting it the same way, but it's a little different. You'll see why. This time, I'm going to call this whole length A. And now I'm going to say this length is B. Okay? Clear? So now to find the length of this whole square, it would be A squared, correct? Hold on. A squared. Now I'm going to do the same method. I'm going to find the individual components, okay? So this is, what is this, right? So we know this is B. What is this length? This length, so this is a little bit more complicated than the previous one, okay? This length is what we call A minus B, correct? Because this is B. So this is A minus B. Okay. Times B. Correct? Okay. Now we have this also, which is the same as this, right? So it is twice of this. So let's just make it nicer. It is 2B times A minus B. Okay, because I have one of these rectangles is B times A minus B. There are 2 of these, so I just times 2 in front, okay? This one is easy. This is simply b squared, correct? B times b. What about this? This is a minus b times a minus b. So this a minus b squared. Okay, so you can see this thing is what we want to isolate. So let's, okay, before we do that, let's just open up this bracket first, okay? So this is 2 times a times b, so it's 2ab minus 2b squared, 2 times b, right? Plus b squared plus a minus b squared. Okay, so now let's simplify this. Let's try to make it simple before we do any kind of shifting around. So minus 2b squared plus b squared. So these are like terms. Okay, I've mentioned previously, like terms basically same coefficient. So this minus b squared, okay, plus a minus b squared. Now I'm going to shift this to the left, okay? So what I do is I bring it over. I get a squared minus 2ab plus b squared equals a minus b squared. So this is exactly number 2. So there you have it. That's the proof for the second one. Now we do the third one. So let me erase this so I can get some space going on here. Okay, so I'm going to do the last one, which is a plus b times a minus b is a squared minus b squared. Okay, so it's a similar thing. I'm going to draw a square again, but this time it's a little bit different. Okay, I'm going to section off one small square here of length b on the side. Okay, and I'm telling you that the big length here is a. We want to focus on this area here. Okay, so this area here, the obvious way to do this is simply a squared minus b squared. It's the big square minus the small square, right? So of course there's another way to do this. So we're going to section this off here like this, and we're going to find this two area individually. Okay, so this area in black that I'm shading right now, we have to find this area. We know this length is a minus b, correct? So this is a, because this is length a times a minus b. Am I right? Then I have to find this other area, which is, this is b, and this length here is a minus b, right? So this is going to be b times a minus b. So we've done something similar when we are talking about expanding and factorizing linear algebraic expressions. Because these two are the same coefficient, we can factorize it out basically and then add this up. Okay, I've explained this in expand and factorize linear algebraic expressions, so you can go back and watch it if you're unsure, but this is a valid move basically. Okay, you just have to factorize out the common term, which is a minus b, and then you just take out a plus b and put it in brackets here. So there you have it. This is exactly point number 3. So proven. So that's all I want to talk about for today. I just want to show you how you can prove these 3 identities. Of course, like I said, you do not have to prove them at all, but it's good to know. It's interesting. So that's all. Thank you for watching. Have a nice day.